Okay, dear students, we continue that the ELEC-DIGIE S1 A, now continue, this is S1B. We left this topic over there. Now the next is the binary number system. In binary number system, which is the most suitable number system for the digital system, has a base is equal to 2 and it has two digits 0 and 1 called binary digits, as I already explained that by from here and the digits from here, so each is called 1 bit. Again, it has a weight is equal to base raised to power position, the same way which we have carried on the concept of the decimal number system and so on. The magnitude is called the sum of the bit into weight. Okay, formal notation is this group of bits. Now we call 4 bits is called nibble, 8 bits is called a byte. The byte is consist of 8 bits. Okay, that's you have to keep in your mind. So let us take now an example. In this case, we have a number which is we have a number as a 101.01 binary number. You would like to convert it into decimal number system. We again follow the same rule. There is a base raised to power 0 and multiplied by its here with the base raised to power 0 and bit multiplied by the weight. This we call the weight. This is the weight and the bit corresponding bit. So here is the bit 1 into 2 raised to power 0. 2 raised to 0 is 1. Then the next bit is the 0. So 0 into 2 raised to power 1, which is 2. 2 raised to power 1 is 2. So we have got that value, and then we have the 2 raised to power 2, which is 4. Okay, so that is the 4. So this is the raised to the power 1, this is raised to power 2, this is raised to power 0. These 2, 1, 0 are the powers. Here these are the result of those bases. 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4. And similarly on the other side, we have got the 2 raised to power minus 1, 2 raised to power minus 2, which is 1 by 2, 1 by 4. So if you calculate all these, you get ultimately the last answer 5.25 to the base 10 in the decimal number system. So this was the binary number system, and this is the decimal number system. Now how we convert the decimal number to a binary conversion we divide the number the decimal number by base of 2 repeatedly till the number is less than 2 or 0. Take the remainder as either 0 or 1 as a coefficient. Take the quotient and repeat the division. So let's say this is the number 13 in the decimal number system. We would like to convert it into the binary number system. So when we divide, we repeatedly will be dividing this by 2. 13 by 2, the quotient is 6, remainder is 1. Then 6 divided by 2, this is the same number. The next we repeatedly divide the remainder. Here the quotient is being divided regularly, so repeatedly. So 6 divided by 2 is 3, the remainder is 0. 3 divided by 2 is 1, the remainder is 1, and we are left now with the 1, so we put that 1 over here. So this is called the most significant. This one is the most significant bit, and this is the least significant bit. We start from here, from the most to build the number, which is now A3, A2, A1, A0. In this case, we have the most significant bit, which is the 1, 1, 1, 0, 1. 1 is this one is the most significant bit. 1, 1, 0, 1 to the base 2. So this is the conversion of the decimal to the binary number. Here is another example. You can see, let's say this is a number 55 to the base 10, which is in decimal number system, and that is given by this 110. How we now convert binary number to decimal number system? So what we do again, we use the radix or the base raised to power 0 and multiplied with the respective bit. Now we start from the, obviously here 2 raised to power 0 from the LSB, the least significant bit. Okay, one thing you have to keep in your mind. So what we'll be getting to convert it back to the decimal number system: 2 raised to power 0, 2 raised to power 1, 2, 3, 4 and 5 and so on and so forth, and with each corresponding bit. 2 raised to power 0, the corresponding least significant bit is 1. 2 raised to power 1, the next is the bit is 1. 2 raised to power 2 again is 1. 2 raised to power 3, 0. The corresponding digits we are putting there to get the weight. So if you put all these the powers and get the values, then the resultant is equal to 55. So this is how you convert a binary to decimal number, binary number to decimal number. Now to convert, we have done that. Now let's see that division again, decimal to binary number. Let's say this 55.375 is a number which is consisting of the whole number and the fractional part. So the whole number part will we take separately. We deal with, we divide 55 repeatedly successively by 2. So what we get in this case, 1 1 1 0 1 1. So this is the most significant bit and this is the least significant bit. So how you build that, from starting from the most significant bit 1 1 0 1 1 1 1 1 0 triple 1 to the base 2. This will make a binary number. Now coming to the how we convert a decimal fractional number into the binary number. So what we do, whatever the fractional part number is, we multiply it repeatedly with the 2 till we get the last the fractional part is 0. So we 0.375 multiplied by 2, we get 0.75. We look for the overflow. Here the overflow means whatever the number we multiply on the other side of the decimal, if we get, we put over here. If we don't get whatever, we put 0 over here. So in this case is the we have got the so here what we do, we multiplied, we get the overflow. Obviously in this case is 0.75. we don't have an overflow over here, so 0 we put over here. Then we multiply, what we get 0.75 when we multiply by 2, which is 1.5. overflow is 1, we put overflow here. And again the remaining, the fractional part, we multiply 0.5 0.5 into multiply by 2, which we get 1. Now he got here the fractional part is totally 0. So if it keeps on you are getting the fractional part, you can go up to 3-4 digits numbers, and then you can stop over there because it may not terminate completely. But anyway, in this case it is terminated, so not necessary that you get the total termination. You get 0.0001 something, so still you can get stop over there to 3-4 digits. Here overflow is 1 again here. Now we will start from the here. This is called, now the 0 is called the first, whatever the number we get is the most significant bit. This is the most significant, and the last one which we get, we terminates the fractional part, is called the least significant bit. So we start from the put the dot here. The first most significant bit is 0, so 0.011. this will be now the fractional, the answer, the conversion of the decimal to the binary number system. Now we reconvert. How we do reconversion? Again, we take on from here most significant bit, you multiply with the 2 raised to power minus 1, 2 raised to power minus 2, 2 raised to power minus 3. From most significant bit we take, that is the first is 0, the next bit is 1, then multiplied by 2 raised to power minus 2, the next is 2 raised to power minus 3, and so on. We put these respective bits and the respective powers of the base. So what we get, if you calculate, you get the 0.375 to the base 10. So that's how we convert. The total number is 55.011. that is the 55.375 is now expressed, is converted into binary number. Now the decimal fraction to the binary, already we have done that. Again, This is the, you can go through as the same procedure we apply. This is the most significant, this is the least significant, and the same again. It has been another example, 0.625 is being converted into the binary number. So you do multiple example, take the any Thiraja book or any other book and have, or make your own fractional number, because in the exam you will be asked from any number, but method and procedure will be the same. So you should know how you adopt this method to solve the problems. These are some important powers. If n is 0 to, let's say, 1, 2, 3 and 7 and so on. So 2 raised to the power n, we add 1, 2, 4, 8, 16, 32, 64, 128. These are the multiple, the powers when you raise to a power. So very, very important some numbers we use in the digital electronics. So the similarly 8, 9, 10. So when we get 1 kilo 1024, then we have 1 mega, 1 giga of the whatever the data when we express in the electronics, megabyte or gigabyte, yeah, gigabit or terabyte, so these numbers follows the 2 raised to the power of the n, which is the respective number. We have 8, 9, 10 up to 40. Up till now we have a terabyte storages, so we can use this 2 raised to the power 40 means 1 terabit, sorry. Okay, now let's do some addition. We know the very simple addition method in the decimal number system. We will now use the same analogy to the binary number system we would like to apply. So in decimal number system, suppose two numbers are 55, 55, we add 5 plus 5, we get 0. Okay, what we have, the 1 is carried over here, so in the base 10 we have got. So what we have then, we add another number 5 plus 5, which is 10. 10 plus 1 is 11. Now here we would like to now explain the binary arithmetic for the binary number system 0 and 1. We have some conditions for the addition, subtraction and multiplication. For addition, we have 0 plus 0 is equal to 0. Since we have two numbers 0 and 1s, so we will be adding and subtracting and multiplying these. So in case of when we add two zeros, we have sum and a carry. So sum is 0 and carry is 0. Similarly, 0 plus 1 is 1. So 1 is the sum of the two numbers. 0 plus 1 binary number is 1 and the carry is 0. 1 plus 0 is equal to 1. 1 is sum and the carry is 0. While 1 plus 1 is equal to 0, as the sum is 0 and the carry is 1. Now this situation is similar to that, because since we have the highest number is 1, when we add two highest numbers, what we get is that we don't have the other highest number. So we, just like we have in decimal number system, when we add 9 plus 1, suppose, so we have the 9 is the highest. When we add, so what we have, 9 plus 1 is equal to, we put a 0 and 1 is carried to the next number. So similar situation is here. We have the sum is the 0 and 1 is carried. Now in subtraction we have 0 minus 0 is 0, the difference is 0 and the borrow is 0. 1 minus 0 is equal to 1, the difference of these two numbers is 1 and the borrow is 1. We don't need to take borrow because it is the higher number, 1 is greater than 0. 1 minus 1 is equal to 0, the difference is 0 and the borrow is 0. Now here we have 0 minus 1 is equal to 1 and the difference, in this case difference is 0, the difference is 1 and the borrow is 1. Now this is a situation like we have the 0 minus 9, we have the case or the smaller number, we take one borrow. When we take one borrow, and the one borrow is taken from the next number, because 1 is higher and 0 is smaller. When we subtract the smaller number from the higher number from the smaller number, we have to take borrow. So just like 0 in decimal number system, we have 0 minus 9, we have to take 1 borrow, so it is 10. In that case, the decimal number system, 10 minus 1. Let me just show you here. Suppose we have the subtraction of 0, we subtract these two numbers, 0 minus 9. So what we take, that we have to take 1 borrow from the next some number, which is when we take 1 borrow, in this case that one will make it 10. Okay, so 10 minus 9, then what we say, that is equal to 1. Okay, so that is 1. So we took 1 borrow from the next number, okay, so which makes 0, 1 and 0, 10. So 10 minus 9 is 1, so 1 is carried. The same situation is here. So since it is the highest number, so 0 minus 1, we take 1 borrow, which is 1 0, and from 1 0, actually this is 2 in case of binary number system. So 2 minus 1 is 1. So we took 1 borrow and the difference is 1. Similarly, the multiplication is straightforward. 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is 0, 1 into 1 is 1. Now we add two binary numbers. Let's say this is a binary number which is 61 to the base 10 in decimal number system, and in the binary numbers is 1 1 4 1 0 1, and this is 1 0 1 1 1. These, when we add two numbers, the number which we are going to add these two, we place the upper number we call oggend, the other call is addend. When we add these two, 1 plus 1 is 1 0, because we already, like we have 5 plus 5 is 10, 1 0. Okay, so in this case we have the minimum number is 0. Okay, so when we 5 plus 5 is added, we don't have the higher number. 5 plus 4 is 9, but 5 plus 5 will be, next number will go to the 0 and 1 will be carried. So in this case the carry is 1. So 1 plus 1 is again 1 0, which is 0, and 1 is carried. Now this time 1 plus 1 is 1 0, and 1 0 plus 1 is 1 1. So we have 1 answer. So 1 we will be putting over here as a sum, and 1 will be carried. Similarly, 1 plus 1 is 1 0, 0 is over here, and 1 is carried. 1 plus 1 is 1 0, again 1 1, we had 1 here, 1 is carried. 1 plus 1 is 1 0, 0 is here, and 1 is carried. So the sum is now 1 0 1 0 1 0 0, which is 84 to the base 10. You can convert it into, from binary to decimal, you will find these numbers. Similarly, binary subtraction, what we have, there are two numbers now. This is 77 to the, these are in base 10. We call the upper number is called the number which from which we are going to subtract is called minuend, and this is called the subtrahend, the number which you are going to subtract, and the result is the difference. So 1 minus 1 is 0. Okay, that is simple, straightforward. Now 0 is a small number, 1 is a larger. We borrow 1 from here. Here the 0 is left. So when we borrow 1 here, it will be 1 0. 1 0 minus 1 is 1. So because the 1 is maximum and 0 is the minimum. So 0 was here, so we take again borrow from here, so it will be 1 0. So 1 0 minus 1 is 1 again. We left here 0, 0 minus 0 is 0. Here is 0, so we borrow again 1 from here, it will make it 1 0. We borrow from here 1, it will make it 1 0. So 1 0 minus 1 is 1. Since we borrowed 1 from here, from 1 0, 1 0 minus 1 is 1. So that is remain over here 1. So since that has been borrowed, so there is 0 is left over here. So final difference, the result answer is 1 1 0 1 1 0, which is the base 2, and this is the base 10. So if you put that, convert it into the binary to decimal, you get the same, the 54 answer. The binary multiplication, what we do, we have the multiplicand. Suppose these are two numbers, 23 to the base 10, 10 to the base 10. So answer we will be looking for. Multiplication is a similar way we do in normal, but only the for rules for the additions, arithmetic rules will be followed. So multiplying by 0, you get all 0. Multiplying by 1, you get all the same number. Again, the second we put here the 1. Okay, this is 0, this is 1, then again 0, and this is again 1. So now we add these two, all these three, 1 2 3 4 together. So 0, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 1 0, 1 is carried, 1 plus 1 is 1 0, 0, 1 is carried, 1 plus 1 is 1 0, plus 1 is 1 1, which is 1 here and 1 carried. So 1 plus 0 is 1 and 1. So this is the final result of the product or multiplication, which is 1 1 1 0 0 1 1 0, which is 2. Okay, now let's see the last binary division, which is the mathematical arithmetic operation. Let's now divide two numbers, 125 divided by 25, which will be equal to 5. This is the decimal number system. In the binary number system, the 125, if you convert it, it is equal to 1 1 1 4 ones, 5 ones, I think, yeah, 5 1 0 1 to the base 2, and the 25 is 1 1 0 0 1. So what we do here now, we are going to now divide. So the dividend, we have got the number 1 double 1, 5 ones here, 0 1, and the divisor we have got double 1 0 1. It is just like we divide the in decimal number system. Same method we apply. Let's say in the first, when we multiplied by divided by 1, so what we get 1 1 0 0 1. So here when we subtract, 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 1. So what we get here from this division of the first we multiply with the, when this number divisor is 1, we get 1 1 0 0, sorry, 1 1 0. So 1 1 0, you can see now this is, if we bring next bit down, which is 0, it will make the number 1 1 0 0. Now this 1 1 0 0 is still smaller number less than this divisor. So in order to have the division possible, we have to bring the other number also down. So for that we bring both the numbers down, that is 0 and 1, both digits. So we have to now include 0 over there in the quotient. So we just like we do in the decimal number system. Then what we see, we have got now number 1 1 0 0 1. So now once again when we divided by this number by 1 1 0 0 1, here we put 1, so 1 1 0 0 1. So we get remainder as a 0, nil. We get everything, both terms are cancelled out. So answer is now 101, which is the 101 to the base 2 is equal to 5. So if you convert the 5 from the decimal to the binary, then dividing by 2, 2 2s are 4, the remainder is 1, 2 1s are 2, remainder is 0. From most significant bit to least significant bit we move, and we write 101. So this is a 101 which is the answer. So with this we reach to the end of this topic. See you next time, inshallah. Till then, goodbye and thank you.